everyone, you are welcome. Into this tutorial, we continue from where we stopped on differentiation. So today we're going to be looking at logarithmic differentiation. So now, when are we to use logarithmic differentiation? So when you have a function like x to the power of x, you have a function like sine what? A function like sine x, okay, to the power of cos x, something like that. When a function raised to another function like this, or even if you have a function like u f of x over v of x, we can as well use that is division. Then even the product rule also, if you have product of two functions, so we can still use logarithmic differentiation. So now let's see how we can do this. So I have the first problem here. The first problem said we should find d dx of x to the power of x. So now d dx, that is differential coefficient of x to the power of x. So what we want to do is I want to know what is dy dx of x to the power of x. Now, so the first thing we're going to do here is that let y be function x to the power of x. So now if y is x to the power of x, so what are we going to do here? We are having the power here, this power here. The only thing we can do to the power here to come down is to introduce logarithm to the both sides of the equation, right? So therefore, we're going to have introducing logarithm to the both sides of the equation. So ln of y will be equals to ln of x to the power of x. Now from there, the next thing we're going to do, from the law of indices or logarithm, when you have log a to the power of b, this will be b log what? Log a. So that is what we're going to use here. All right, so we see that here we're going to have ln y, ln of y equals x what? X ln what? Ln x. All right, so from there, the next thing we're going to do here is that we have ln y equals x ln x. What are we going to do? Now from here, we can now differentiate. Let's differentiate with respect to what? With respect to x. That is wrtx. All right, so from here, so now you should recall that whenever you have ln of x or ln of a, differentiation of ln of a, d dx of what? Of ln of a, this will give us 1 over what? 1 over a. So I want you to take note of that, keep that aside. All right, so now going on, so differentiate with respect to x. So from here now, so we're going to have ln y is going to be 1 over y, but this y is what? Is a function of y. If you remember what we did in implicit function, so we're going to multiply this by dy dx. All right, then equals, then here this is product rule. We apply product rule here, d dx, all right, of x ln of x. The product rule, that is going to be what? That's going to be having, we are going to have 1 over y dy, all right, dx, then equals. Now for this, we are going to keep what? We keep x. Let's keep x. Then let's differentiate ln what? Ln x, and that will give us 1 over x. All right, that will give us 1 over x. Then plus, we're going to what? We're going to differentiate. All right, we've already keep x in the first place, so we differentiate ln x and keep what? And keep x. That will be, we differentiate x. All right, then we keep ln x. That's what we're going to do there. Now from there, so we are looking for dy dx. So dy dx, all right, is now going to be 1. We multiply both sides by y because of this y that is there. We have y equals x 1 over x, then plus 1 times ln x, we have ln x. Understood? So we're going to have dy dx is now going to be y. You see that this x, we cancel this x, we have 1 plus ln of x. Now, so we are not going to stop there. So we need to what? We need to move order. So now, we have y here. So we need to recall from the beginning. So if you recall from the beginning, we have already stated that y is equal to what? X to the power of x here. So therefore, we move further, okay, and replace, that is dy dx is now going to be y is x to the power of x into bracket 1 plus ln x. All right, so, and that is our solution. That's the end of the class. I believe you enjoyed the class. Please, if you enjoyed this class, kindly share to your friends so they can learn from this. Thank you so much for watching. Bye bye.